Okay, so let's start with today's training. Our PLC supports Ethernet communication. For example, it can support Modbus TCP protocol and user-defined communication. And if you use LX5V PLC, so some mode have the Ethernet port with and this mode with the N as we mentioned before. Okay, so if you create a new PLC project and choose, for example, you choose as you can see here, if you use LX5V series PLC and your PLC mode is LX5V N, N means Ethernet port. So you can see the parameter option here has the Ethernet settings. So we can set the IP address, subnet mask, and the default gateway for our PLC. And if you choose the PLC mode without N here, for example, LX5V, so the Ethernet settings is not available now. And if you want to use LX5V mode for Ethernet communication, you can use the BD board LX5V ETH. This is the BD board for the LX5V. And if you use LX3V series, actually there are no mode for Ethernet port available in this series. So you can also use LX3V ETH for Ethernet communication. And there are also a setting we need to notice is protocol settings. If we set it as true, and you can see the maximum number of connections supported by the model bus TCP server. At least the number is 2, and the range is from 2 to 8. So as we can see, if we choose it as 1 and check, and he will hint the, the range is from 8 to 2 to 8. So please beware of this limit when you use Modbus TCP protocol. And for the LX5V, there are some special registers for the IP address and the subnet mask and the default gateway. The range is from SD2680 to SD2691. When SM2680 is set to on, the static IP function is enabled, and if SM2683 is on, so the IP identification could be modified. And the new IP address will take effect when PLC is from stop to on or after reboot. And let's go to the LX5V and socket configuration. We can find this configuration from here. Extend function, SNet, and we click new. And you can see we can choose the socket ID, communication protocol, both TCP and UDP support, and the operating mode. It can be PLC can be a server or a client. And we can set the local port, target IP, target port. For the socket ID, it's the number of the socket range is from 0 to 5. And it used to specify links, and each ID should be used for one link and could not use rapidly. For the communication protocol, TCP and UDP support, and the operation mode, it can, if for TCP, client and the server could be selected, and if you choose the UDP, this mode is meaningless. And for the local port, for TCP client mode, the local port will be automatically airlocked by PLC without setting. And if for TCP server mode, the local port range is from 1 to 65,535. If you use Modbus TCP, the port number is 502. So you cannot set this port number if you use other protocol. And if for UDP mode, the local port is range also from 1 to 65535, and the port number 1092 is used for Wacom protocol. A destination IP is valid in TCP client mode or UDP mode, and specified the IP of optic side and the device to be linked, and also the destination port, and also the timeout setting. Let's move on to the SNET instruction. When we create a socket link, create a SNET communication, we need to create a socket link first. So you need to use SOC open instruction to create a socket link. This instruction has three parameters. The first is the socket ID. So as we just mentioned, the range is from 0 to 5. And the second parameter is the start device that stores the data information of the socket link. And the third parameter is for the start device to store the state information of the links. So when the instruction is triggered, the device specific in D1 and the D2 will be used in other SNET instructions, which using the same socket ID. So if you create this socket ID, the same socket ID can be all these parameters can also be used for SOC, SEND, SOC, RECV, receive, and SOC, CLOSE, socket close, and SOC, MTCP, for the Modbus TCP protocol instruction. And this is the corresponding relationships. The first is the local port number. And for example, if the D1 here is D100, so the D100 is the local port number. D101 is the to D104 is the destination IP. And the D105 is the destination port number, and so on. And if D2 here is D200, so when the third parameter is the bit address. So if the D2 here is M100, so if M100 is on, So it means the socket link is connecting. And if here the M101 is on, so it means the connection is complete. Okay, let's move on to the second instruction. It's about to close the socket link. SOCCLOSE. It just have one parameter, is the socket ID. So when this instruction is triggered, it means we close this socket link. And the third instruction is is used for the SNet Modbus TCP communication. It's SOCMTCP. It, as you can see, have 5 parameters. The first parameter is the socket ID, and the second parameter is the combination of the station number and the function code. It's the same as the IS instruction for Modbus RTU. And the third parameter is for the Modbus address we need to communication. And the fourth parameter is the length. And the last parameter is for the sent or received start device. And just notice this instruction must be used with the SOCOPEN instruction. So after the link is established, this instruction will work. Let's see an example for how to use the Modbus TCP communication for LX5V. So in this demo, we communicate between two LX5VN PLC with Modbus TCP protocol. The first PLC, number 1 PLC, we set it as the Modbus TCP client and set the IP address. And for the second PLC, we set it as a Modbus TCP server. And for this case, we need to set the port number. Here it's a certain number, 502. And also set the IP address for the number 2 PLC. And after we set the first things, we need to set the first PLC's IP address. So we need to set it here. Set the IP address we need. And then we need to set the socket link here. As this picture shows, the target IP is the second IP address. And the target port 502. And this is the example program. So as see, at first we reset this. We need to reset these registers. And first we need to create a socket link. And after the link was established, we use SOC MTCP instruction to read and write instructions, to read and write data to other PLC. And after finish all of this, we use SOC close instruction to close the socket link. I made a video for this, so we can see how it works. First, if we use a PLC as Modbus TCP server, the first things, as we just mentioned, we need to set the IP address. And here I use Modbus port to simulate a Modbus client, a Modbus and as we can see, the M1 for the PLC in Modbus address, it was, wait a moment. You can check this table. For LX5V PLC, if PLC as Modbus slave, this table is for the address, the Modbus address for different registers. As we can see it here, M1, the address is 4096. So M2, M0 is 4096, and M1 it will be 4097. So as we can see it here, if we want to use a PLC as Modbus TCP server, no need to set the SNET parameter here. We just need to set the IP address. And also I create the link. Like you can see it now. The simulator gets the value from the PLC. M1 is on, and only M5 is off. So M5 here, Modbus address 4101 is 0. And it can be read and write. Now I triggered M5. So as you can see, Modbus address 4101 is 1 now. And then we can see the word address D10 and D12. As we can see the address here for D register D, it also Modbus address for D0 is 4096, and also, and in this case, if the if it's D10 here, the address will be 4106, as we can see in this video. And the list address 4108 is for D12. So now let's change the value. And we can see the corresponding registers, the value changes. Okay, this is how we use the Simulink to communicate with our PLC when the PLC work as a TCP server. And if we use our PLC as Modbus TCP client, it will have more parameters to set. And the first step is also to set the IP address of our PLC. And the second step is to set the SNet mode. For here, we set the communication protocol as TCP and choose the operate mode as client, TCP, Modbus TCP client. And we set the target ID. Here, this target IP address is the PC's address, because I also use the Modbus slave simulator to communicate with our PLC, and also set the target port. The first thing is also to reset the registers for this instruction, SOC OPEN, to reset all these registers. And then this is we set the parameter of SOC and TCP to set these parameters. After that, we create a socket connection using SOC OPEN instruction. And then use SOC TCP instruction to read. Here I use the function code is to read coils. So if we use other function code, we can write the bit address and write the word address and read the word address. So let's make some configuration in Modbus slave simulator. And choose Modbus TCP protocol here. And now we run the project. As we can see it now, for here we set the first model bus address 4096 as 1, so we can read this value and set it to the D40. So when this address is triggered, the D40.8 bit will be on. And if we trigger another bit address, so as you can see, the corresponding address will be on. And also we can write the bit address here. For here, we choose to write the Modbus server address is 4104. Here, this address, to set it as on. So when I triggered M100, this address will from off to on. And can off again. And let's move on to write the word address. So here the address is 100. So here 100 we set, and we want to write it the value 123. So as you can see, this value changed. So we can also read the value from our Modbus TCP server. So here the address is 105. The value is 987. So when we triggered this instruction, it also gets the value and save it to the D170. Okay, if you have interest to this demo, you can download it from our Wacom Support Center. And from his demo, and the protocol here. And we also have a video on YouTube. It's about the Modbus TCP communication for LX5V. The same video and the program I just showed. Okay, do you have any questions about the usage of LS Modbus TCP protocol in LX5V? Do you have any questions about here? And please notice the SNet port of LX5V and not only just support Modbus TCP protocol, it can also use custom protocol, but it's not today's key point, so we will not mention in today's training. And in our Wacom Support Center, you can also find how to use it from here as net communication. And it also shows the SNet applications for not only for Modbus TCP, but also for free TCP and free UDP here. It also shows the program. Do I have use every time we use? It's no need. It's no need. Just when you want to close this socket link, so you use SOC close instruction. Okay, let's move to the SNet BD board. Today we will just mentioned LX3VP SETH BD board for SNet communication, but just remember we also have the same function BD board for LX5V, but it can only be used for the corresponding PLC series. So you can only use this BD board for LX3VP and LX3VE mode. Cannot use this BD board to LX5V. It was the total Modbus link, the TCP link is 8. As you can see it here. Modbus TCP servers range is from 2 to 8. So one PLC can connect to 8 Modbus TCP server, or just 2 server and 6 client. No, but the socket ID, the range is just from 0 to 5. Okay, so let's can continue to the BD board. You can see this BD board only have one SNET port, and you also have the indicator to show the state of the BD mode. It's also the same. It's the maximum of 8 device connections, regardless the master or slave. It's the same as the Ethernet port built in our PLC. And if the BD mode is well connected to the PLC, the power light will be always on, and the COM LED will be blink. And the data LED, when you connect to the SNET, then it will light is lit, and the link LED, the data lights blink when the communication with network is normal. And just notice if the power light and the COM light blink at the same time in 1 Hz, it means the PLC doesn't support this SNET board. So when it happens, you need to check this to make sure the firmware version is supported. And this is also an instruction we need to introduce is CPAVL. This instruction have 3 parameters. The first parameter is the start address for the D registers, for the parameter table. So you can set the IP address for the BD module and the port number, gateway, and subnet mask, and to create the MAC address. The second parameter is the starting address of M registers, which shows the state of BD module. And the last parameter is for the connection number. It set this number according to the SNET port. So if you connect the BD module is here, the module 1 base. So the value here is 1000. And if you connect this BD board to the second place here, so the number of the last parameter is 1100. Just pay attention for this BD mode, SNet BD mode. It just only support Modbus TCP, not like the SNet port built in LX5V. It can support free TCP or UDP TCP. For the details of address identification, you can check this table. For D device and M device. Okay, let me show you how to use the BD module, SNet BD module on LX3V series. The first things we also need to set the IP address of the BD module. So here we choose the starting address. The starting address is D 300 and M 300 to. So for D 301 to D 304 is the BD module address, IP address. And all this part is to set the BD module SNet parameters. And then we need to set the protocol. We choose the PLC as the Modbus master. So we set D323 as H20. It means we set the PLC as the Modbus TCP master. So if we want to use PLC as Modbus TCP slave, we write 2 to the same address. And then we set the slave IP address and the port number. After we set these parameters, we triggered CPAVL instruction. Just remember we should trigger this instruction after we set all the SNet communication parameters, not before. Otherwise, it will show errors. And then after we made the connection, we use RS2 instruction to get the value and write the value to other Modbus device. Let's see this video. Here I use our HMI as a Modbus TCP slave and the PLC as the Modbus TCP master. And the first part, we set the PLC's IP address. This part. And set the port number. And then set the Modbus, the IP address of the Modbus TCP slave. Then we set the subnet mask. And here we just connect one device here. And then we set the slave IP address of slave device. So here with the HMI IP address is 39.240, and set the PLC as TCP master, the same port number, and this is for the timeout. And then we triggered CPAVL instruction. So now you can see the program is running normally, and we can get the bit and bit value and write the bit value. As you can see now, I triggered M10. If I triggered M101, so it will when I triggered M101, it will send the data to PLC and triggered the address is 0. The length is 1. And the value we sent is 1. And we set the communication port is from the SNet port on the BD module, the first BD module, so it's 1000 here. And the 1 is the Modbus slave station, and the 05 is the write bit address write function code. So as we can see, now the PLC can control the HMI's address. And then let's move to the word operation. Also use RS2 instruction, we can get the value from HMI. And we can also write the value to the HMI. For the else instruction, I forgot to make some introduce. It have 5 parameters. The first parameters is about the slave address and the communication command. As we can see it here, 1 means the slave address, and O1 and O5 is the function code for Modbus protocol. And the second parameter is for the starting address of the slave. And the third parameter is for the length of the data we want to read or want to write. The fourth parameter is for the starting address, which stores the data we read or store the data we want to write to the other Modbus TCP device. And the last parameter is the connection number. For here, we just have one connection, so we set it as 1000. Okay, 1000 here. And if there are 2 Modbus TCP slaves, so we need to set other device IP address and use the IS2 instruction with the end parameter. For example, if we have 2 devices, so the second instruction, we need to use 101. Okay, and our SNet module can also use to make the PLC as Modbus TCP slave. So it will be a much simpler program. So here we just set the IP address of the PLC and the port number. And the gateway, the mask net, subnet mask. And use to set the corresponding register as 2 to make a PLC as Modbus TCP slave. And then we established the connection by using CPAVL instruction. And now we can use Modbus TCP protocol to read and write the PLC's address, as we can see in this video. So when I triggered address 0 here, Modbus address 0 here, as you can see M0 is on, because the relationship Modbus TCP relationship address for the LX3V you can check the Modbus address table here. For bit address M1, the Modbus address is 1. And for the word address D0, the Modbus address is also 0. So here in PLC's, in HMI's program, this address is Modbus address 0, and this is the Modbus address 10. And when we change a value, and you can also see the D0 and the D10 also changed. Okay, this is all the information I want to introduce in today's training. Do you have any other questions about the SNet BD module? After today's training, I will share today's demo in our group. So if you have some interest to test, you can have a try. Okay, so if you have any questions, you can leave your message in our group. Let's move on to the to choose a lucky man to get today's prize. Today's prize is also the it's also the tool set provided by Wacom. And now today's participant is also 27. So despite me, except me. So next, to figure out who is the first lucky person. Oh, it's number 5. 1, 2, 3, 4, 5. Okay, congratulations, Mr. Tan from Autobase. Oh, congratulations. Please provide your email address. And let's choose the second person. Oh, number 2, a pass from Mekong. Yeah. So please provide your email address to get the today's prize, and please make sure our prize also have some limitation rules. So if you use all if you don't submit the after class exercise for 3 times, the winning qualification will be cancelled. So please just remember to submit your after your exercise in time. Okay, today's training will be finished. Thanks for your attendance. Tomorrow we will continue training about the serial communication. And the last training is about the LX3V4PG module on Friday. And the final exam will take place in the next week. It's from next week. It's from for a moment. It's from May 22 and to May 24. And we will arrange another lesson is to discuss all the after class exercise during in May 20. So for now we will have we only have 3 training lessons remaining. So please inform your colleague to attend in time. Okay, see you next time. Goodbye.